Photography is the process of using light to create images of the real world. And historically, we've used visible spectrum. So when we're talking about the visible spectrum, we're talking about things varying from 700 nanometers on the long wavelength side down to about 400 nanometers on the short wavelength side. So going from red all the way to blue. However, the electromagnetic radiation spectrum is much larger than that. The electromagnetic radiation spectrum goes from gamma radiation all the way to long wavelength radiation. And we can actually create images using these various different forms of radiation. The one we're going to work with here is infrared. So infrared is the name infra means below, like infrastructure is something below a structure. So infrared means it's lower than red. What that means is lower energy than red. So if you look at this graph, increasing energy goes this direction, and increasing wavelength goes this direction here. So if we did look at animation and so forth right here, here's an animation of electromagnetic waves. We can see here um, that they're oscillating electromagnetic fields. And so one plane is electrical fields, one plane is magnetic fields. And together they create what we know as light. And again, our eyes, human eyes, can see between about 400 and 700 nanometers wavelength. In other words, this portion of the spectrum here. So, but if we have an adapter for our phone, we can start to image things in the infrared. Okay, it's lower energy than red light, or lower energy than all visible light. And here's two popular models. So one is produced by the FLIR Corporation out of Santa Barbara. The other is Seek Corporation, which is, I believe, in the Bay Area. And you can see the imagery that they're taking here. So we plug this FLIR camera into the phone, and basically the information that is taken from this lens here is then sent through to the software, the FLIR software, and giving that image. And we can see the same thing here. So the human eye, we would see that dog as black against a green background. But when we're talking about infrared, the dog here is obviously warmer temperature than the background, and so the dog stands out. So we're talking about infrared radiation. It's used a lot in science. There's three major telescopes that are up right now: the James Webb, which is recently launched, the Hubble, which was launched a number of years ago, and then the Spitzer Space Telescope. And they're looking at various different astronomical objects, but they look at various different aspects or different portions of the infrared radiation spectrum. What we're looking at here is two images of a nebula in the Milky Way. And nebula is basically, maybe the remnants of a supernova, or the beginnings of star formation, actually. That's just dust, which is, blocking our view of what's going behind. So here, this interstellar dust and so forth creates these beautiful images here. But if we look for infrared light, the same exact image, you'll see that here's those reference stars. See that star and that star match, and that star there and that star match. And we can see the stars behind it. So infrared allows us to see things that we can't see with visible light. So here's just an example of visible light versus infrared. Well, notice one of the big differences you'll notice is the glasses. Notice that the glasses here are cooler than is my face. And so what's happening is the face is emitting infrared radiation, and whereas the glasses seem to block the infrared radiation. We can see that right there. You can also see that my forehead is warmer than where my hair is. You can see where the hair is right here. The hair is like acting like a blanket. It's actually keeping the infrared radiation in. It's reflecting it back to the scalp, and so that the what you're seeing here um, is that you're going to see warm forehead and what appears to be cool hair. The surface of the hair is cool. The underside, of course, would be warm. So when we talk about uh, satellite imagery, oftentimes infrared is used. This is an infrared image of the San Fernando Valley. So Cal State Northridge would be right about here. And as we're looking at that there, that we can see that the uh, there certain sections are hotter than other sections. So, for example, right here, this tends to be a hotter zone. If we look out here up in the mountains, it tends to be cooler. And if we look over here, it's going to be substantially cooler. This would be the portion there out in the ocean, which obviously the water is absorbing that heat. Now, we can also look at what's called the urban heat island effect. If we look at imagery here that we're going to put into Google Earth. So in this activity over here, this is a CSCL activity here focusing on the urban heat island effect. And if you click on that, there'll be a whole lesson there in terms of radiation balance and how to do the type of infrared imaging that I'm describing here. What I've done is I've already imported into the Google Earth an image of the northern Los Angeles County here. And if you can zoom in right here, you can see that that is the infrared image. Let's go in and start looking at some details. So Cal State Northridge is right about here. And as we zoom in, you'll notice that to where the campus is, where that location right there is, it actually is probably cooler in general, at least where the quad is. But then if you see Reseda Boulevard, it's dark red, indicating that the surface temperature there on average is higher. And of course, that's because of all of the asphalt, the concrete, and things which absorb and retain the heat. Whereas in dealing areas which are greener, where there's more evapotranspiration, like a golf course like here, we're going to see that this is going to be substantially cooler. And so if you go to some place where there's a lot of asphalt, like the airport and so forth, it'll be much redder. And then if you go to places where there's more water, like, of course, the ocean, or even places that are approaching the surface of the ocean, in other words, like the Santa Monica Mountains on the ocean side, it's going to be cooler as well. And so infrared imagery can help you tell things about your environment. So these are images that I took with the Seek camera attached to an iPhone. And here you can see the laptop computer that right in the front here, that not all portions of the laptop are the same temperature. The screen tends to be cooler. Right along this junction here, it appears that probably the battery is located in there, probably warming up. And then if we look here, I set my hand on the desk right here, and then I picked my hand up, and you can see the trace of where my hand was. So it would be invisible to the using visible light, but here we can see that it is shows up as a temperature differential. So here's a movie. One of the features with these infrared cameras is they allow you to take movies. So let's go ahead and watch this movie. Let's try it again. So you can see what I'm doing right here. Here's one of my students, and you're getting to see in real time what he's doing. You can see him typing. You can actually even see the thermal effect there again. Like he'll put his hand on the keyboard or the desk, and then he'll pick up his hands, and then you can see the trace. So again, infrared radiation allows you to see things that are invisible with visible light. So here's just a candle burning, and so we can see that you can see that there's obviously a little bit of wax which is dropped down here at the bottom, and the temperature differential is quite substantial from 480 degrees Fahrenheit down to about 80 or 70 and so forth. Here, if you look at the screen, you'll see temperature variability going on there in terms of the scale. So again, this is just with the Seek camera. This one is about $160 model that I'm using right here. So there's many different things you can, that are exciting and interesting to photograph with infrared camera. Again, just one of the adapters you can plug right into your iPhone or your Android phone. Here's just a few of those ideas here, but really it's the creativity that these things allow, which really gives students and even teachers the ability just to do some cool exploration, understand things about their environment, and answer questions or generate questions based upon the data that they can find from the infrared imagery.